Welcome. Today we will solve Leetcode 2825, make string a subsequence using cyclic increments. As a quick note, this is a re-recording. The previous video I created got stuck during the middle, and I was unaware of that until after I uploaded it to YouTube. So my apologies. All right, so let me basically go over the entire problem again. So we are provided two strings, string 1 and string 2, and they want to know if we can modify string 1 so that string 2 is a subsequence of string 1. They allow us to perform an operation where we can convert A to B or B to C and so on. And when you arrive at the letter Z, you can cycle around so that Z becomes A. And they want us to return true if it is possible to make string 2 a subsequence of string 1 by performing the operation at most once per index and false otherwise. Let's look at these three examples. So the first example, we're given string 1 is ABC, string 2 is AD, and they want to know if string AD is a subsequence of string 1, considering that we can perform an operation for each index, and we'll see if that helps or does not. A and A match, so we can move on. D and B. Remember, the operation they allow us to perform is we can increment from B to C. C and D still do not match, hence we'll try the next letter, C. D and C do not match, however, we can increment C to become D. D and D match, hence AD can be a subsequence of string 2 can be a subsequence of string 1 if we perform the allowable operations. Let's try example 2. A and Z, they do not match. However, we can increment Z to A in a cyclical manner, so that those are a match in essence. Now C and D, they do not match. However, we can increment C to become D, and at that point, we determine that string 2 can become a subsequence of string 1, considering the operations we are allowed. So the return value is true here. Lastly, A and D do not match. The best we can do is increment A to become B. B and D do not match. Hence, we'll try the next string in string 1, which is a B. B and D do not match. And the best we can do is convert or increment B to become C. D and C do not match. Hence, the return value is false. The problem is pretty straightforward, as you can see. So let's go over an algorithm we'll be using to solve this. I think what we'll be using here is a two-pointer approach. So we'll start off by storing the B index as 0, and we'll loop through the characters of A. So now, for convenience, we'll store the length of B. And in this case, it's 2. So for every character in A, we'll ask ourselves 3 questions. Does this current character in A match character in B at B index? If it does, then we can increment the B index. Increment B index. So let me go over that again. So in this case, A and A match. So that would mean 0 is okay. So we can move on to the next increment, the next index, which would be 1. Another question we'll ask ourselves is current character in A 1 less than character in B at B index. So for this example, C, let's look at C. Just suppose we're at C. Ask ourselves, is C one less than the letter D? And in this case, that would be okay. So we would increment our B index. In essence, it's a match, considering the operation they allow us to perform. Our last check, or last question we'll ask ourselves is current character in A set to Z and character in B at B index set to A. If that's the case, we'll also increment the B index. While we will be incrementing the B index for each one of these, we'll check if B index is or equals B length. What do we know if they're equal? We know that at that point B is eligible to become a subsequence of string A, so we can return true. If this loop has completed, then that means that string B cannot be a subsequence of string A, so we would return false. Alrighty. I think that should be enough for us to get started. So let's do that. First thing I will do is set the B index, or the pointer for B. So B index, we'll call this, we'll call it BI for B index, and I'll call it B len for the length of B. Set this equal to 0 and the length of B. Now we will loop through all of the characters of A. So for A in A. Now we will ask ourselves the three questions. If A equals B, BI, then we will increment BI. Else if, what we can do is we can check if that letter is, what did we say, one character less. So what we can do there is use the ordinal function. Because in Python you can't compare something like C minus D. In C, something like C you can, but in Python you can't. So we need to use the ordinal. So the ordinal of A, we want to know if that's one less than the ordinal of B. So B, BI. So one less, we'll use that there. We want to know if that's true. We want to know if the character A is one less than the character at B at that point, at that index. If it is, we'll increment the B index. Also, we'll check if A equals Z and, and what was I doing? B, BI equals A. If that's the case, we can increment the B index as well. And as before, we will check if the index for B is equal to the length of B, which means that at that point we have successfully matched a character in A and B for every index. So if BI equals B len, return true. If we've gone through the entire loop and not returned, that means that there is no possibility of making B a subsequence of string A, considering the operations were allowed. So we'll return false. All right, let's check it locally. All right, looks good. All right, looks good. Again, for some of you, I apologize. I uploaded my first video and it got stuck midway through. So I didn't realize that until I posted it. So this is a repost. So my apologies. If you found this video helpful or enjoyable, or if you learned anything, like or subscribe. Have a great day. Take care.